In this video, we will be continuing our review of factoring by looking at these four examples. So let's start with this one. 8q to the 6th plus 125p to the 9th. What we have here, we can check for GCF. It isn't going to work. Grouping will not work. It's not a trinomial. So we can either try the difference or the sum of cubes or the difference of squares. But we have a sum, so we know our only choice will be the sum of two cubes. And remember, it's the same thing as a cubed plus b cubed. So let's try to rewrite this here. So I have 8q to the 6th, and I want to rewrite that as something to the third power. So the number is always the easiest one to do. So 8 can be rewritten as 2 cubed, but the exponent is a little bit different. So what I do is I divide the exponent by 3, which is 2, and q squared cubed will be cubed to the 6th. So that's a little trick there. And then if we have 125p to the 9th, again, we want to rewrite this as something cubed. The number is easy. 125, we can rewrite that as 5 cubed. And if I divide this by 3, I'm going to have 5p cubed cubed. So now we know what a and b are. We're ready to factor. So here it will be just a 2q squared plus b, which is 5p cubed. Remember, the first one is just going to be a plus b. And the second one, we will have this squared. So it'll be 4q to the 4th minus this times this. So minus 10q squared p cubed. And the order does not matter there. Plus this squared, which would be 25p to the 6th. And this you cannot do anything else with. So we have completely factored that sum of two cubes. Looking at this one, I see that it is a trinomial, but its leading coefficient is not 1. So how I would work this is I would take this 6 and multiply it with this 6. So now I have x squared minus 5x minus 36. And the reason I do that is so that I have a leading coefficient of 1, which is what I'm more used to working with. So I set up my two parentheses. I know I'm going to have x and x. And then I need to look for the number that will multiply to give me negative 36 and add to give me negative 5. So in this case, we know it will be 9 and 4. In order for this to be negative, we'll have the negative with the 9 and the positive with the 4. But since we multiplied this by 6 at the beginning, now we have to divide the end result by 6 and simplify. So we have x minus 3 over 2. Divide this by 3. And then this would be 2 over 3 here. Then we're going to slide this number to the front here. So that would be 2x minus 3 times 3x plus 2. And we can check it. That would give us 6x squared plus 4x minus 9x would give us negative 5x minus 6. So this would be how we could factor when our leading coefficient is not 1. On this one, we have the same thing happening. Our leading coefficient is something other than 1. So I'm going to take this and multiply it by the end. So I'll have x squared minus 7x minus 18. Now that's something we're more used to factoring. So I have x and an x. For 18, I'm going to use 9 and 2. I'm going to put the negative with the 9 and the positive with the 2 in order to get negative 7. And since I multiplied by 2 at the beginning, I have to divide by 2 at the end. This will not reduce, but this will. Then I need to slide this 2 up, so I have 2x minus 9 times x plus 1. And if you check it, you would get the same thing you had in the beginning. There are other methods that you could use to factor when your leading coefficient is something other than 1, but I find this one to be the easiest, so that's what I'm showing here. Our last problem is something like this. It looks like a trinomial, but we're working with a fourth degree instead of a quadratic, but it will work the same way. So what we're doing here, we're still looking for a number that will multiply to give us this and add to give us this. So to start with, I know I need x squared and x squared in the front, because that's how I'll get x to the fourth. For negative 24 and a negative 2, I'm going to add. Come over to the side, I'm going to do 6 times 4, excuse me, and we have a negative with the 6. So I know I need minus 6 and plus 4, but I have to put a y squared with this also. So it's no different than these, but now we just have a variable in both places. And then we can check and see this would be x to the fourth plus 4x squared y squared minus 6x squared y squared minus 24y to the fourth. And we cannot simplify that anymore, so we have completely factored all 4 of these problems.